Hi students, in this video class I will be discussing about dielectrics and polarization. We know very well the difference between insulator and conductors. Conductor has free electrons, but whereas insulator doesn't have any free electrons. Now, dielectrics and polarization. So polarization, it is in fact called as electric polarization. Now before going to this topic, let us discuss about dielectric, and before going to dielectric, let us discuss about a behavior of a conductor inside the electric field, right? Now, for example, if you are having a conductor, right? Let's say we are having a neutral conductor, right? This conductor is placed in an external electric field. Right? The neutral conductor, it is having free electrons. So free electrons starts moving inside the conductor because of electric field. Now what happens? All the positive charges will move along the direction of electric field. All the negative charges will move opposite to the direction of electric field. So inside this conductor, there is an external field created. Inside this conductor, there is an electric field. That means external electric field. And because of all these positive and negative charges, there is an electric field created or induced inside this conductor, right? The magnitude of external electric field will be equal to the magnitude of induced electric field. Both are having equal in magnitude, but both of them are in opposite direction. So the external field and induced electric field inside the conductor, they will cancel with each other. That means, net electric field inside the conductor becomes 0. Already this point we have seen in electrostatics of conductors. Inside any conductor, electric field is 0. Right? Now even if you place the conductor inside the external electric field, then also inside the conductor electric field is 0. Right? Now this is about conductor. Now we are having dielectric, right? So dielectrics are non-conducting substances. Right? Non-conducting substances literally means we can say them as insulators. Right? So dielectrics are non-conducting substances. Now, dielectrics are of two types. First one is non-polar dielectric, and other one is polar dielectric. Non-polar dielectric, polar dielectric. So what is non-polar dielectric? So non-polar dielectric means dielectric made up of non-polar molecules. So dielectric made up of non-polar molecules. Non-polar molecules. Now you might have a doubt, what is non-polar molecule? Right? So non-polar molecule means molecule whose dipole moment is zero. Means molecule whose dipole moment is zero. So whose dipole moment is zero. Right? Other one is polar dielectric. Now what is polar dielectric? So polar dielectric means dielectric made up of polar molecules, which is made up of what? Polar molecules. Now what is polar molecules? So polar molecule means molecule whose dipole moment is not zero. Right? Now what we are going to see in this topic, we know if you place a conductor inside the electric field, the net electric field inside the conductor becomes zero. Now if you place a dielectric inside the electric field, what happens for the electric field inside? Now before going to that, we are discussing about dielectrics. Now what are basically dielectrics? Non-conducting substances, right? And dielectrics are of two types. What are they? Non-polar dielectrics and polar dielectrics. What is non-polar dielectric? A dielectric which is made up of non-polar molecules. What is polar dielectric? A dielectric which is made up of polar molecules. Now what is non-polar molecule? Non-polar molecule means whose dipole moment is zero. Now what is polar molecule? Whose dipole moment is not zero. And what is called that type of dielectric? Polar dielectric. Now let us clearly discuss about polar molecules, non-polar molecules, polar dielectrics, non-polar dielectrics, and their behavior inside the electric field. Right? Right. So I can say molecules can be divided into two types. First one, non-polar molecule. Other one, polar molecule. So polar molecule. What is non-polar molecule? So non-polar molecule means dipole moment of the molecule is how much? Zero. What is polar molecule? Dipole moment is not zero. Dipole moment not zero. That means there is a dipole moment. If there is a dipole moment, we should have a positive charge and a negative charge, and both of them are separated by small distance. But here dipole moment is zero. Dipole moment is zero, and we know very well what is the formula: 2a into q. If q is zero, there is no question of dipole at all. That means what has to be zero? 2a has to be zero. Right? That means later I can say 2a into q is equal to 0. If q is equal to 0, there is no question of charge at all. So 1 has to be 0, 2a has to be 0. That means the distance between positive charge and negative charge must be 0. In this case, dipole moment is not 0. So dipole moment is not 0 means what? 2a into q is equal to dipole moment. That means what? The center of positive charge coincides with center of negative charge. Center of positive charge coincides with center of negative charge. So center of positive charge coincides with center of negative charge. Center of negative charge. Center of positive charge coincides with center of negative charge. Then that type of molecule is called as non-polar molecule. Right? But whereas here the center of negative charge and the center of positive charge, they will not coincide. They are separated by a certain distance. That means center of positive charge, does not coincide with center of negative charge, and that type of molecule is said to be polar molecule. So what is non-polar molecule? Dipole moment is 0. And another one, the molecule in which center of positive charge coincides with center of negative charge, then that type of molecule is said to be non-polar molecule. What is polar molecule? Whose dipole moment is non-zero. And another way, the center of positive charge that does not coincide with center of negative charge. Right? Now, and here I am talking about non-polar molecule. And here, so polar molecule. Right? Non-polar molecule. Examples. Second point is over now. Third point. What are examples for non-polar? No poles. I can have CO2. I can have H2. Examples. These are examples for non-polar molecules. And what are the examples for polar molecules? HCl, and I can have H2O. Like that, we can have a lot of examples. Now, here is CO2. This is carbon, and you are having double bond O, and here you are having double bond O. As far as I know, here O2 minus, carbon 4 plus. Where is the center of positive charge? It is here. This is negative charge. This is negative charge. Where is the center of those two negative charges? There is a here only. Center of the positive charge is here. Center of the negative charge is also there. That means both of them are coinciding. If both of them are coinciding, it is what type of molecule? Non-polar molecule. Another example, H2. So that means H2 means I am having only positive charge. There is no question of negative charge. So that means I cannot have a perfect example as a H2 for non-polar molecule. Right? But you come here. HCl. You are having H plus and Cl minus. So center of positive charge, center of negative charge, both of them are separated by a certain distance. So this is plus, this is minus. So there is a dipole moment from negative charge towards a positive charge. So there is a dipole moment. H2O. Now this is hydrogen and this is oxygen. This is oxygen. H plus, O2 minus, H plus and O2 minus. Sorry, H2O. Sorry. Here I can write O2 minus, H plus and H plus. So O2 minus, two minuses are minus plus, one dipole moment, minus plus another dipole moment. The resultant of these two will be in this direction. Resultant dipole moment. So I'll write the resultant dipole moment. So PR. So there is a resultant dipole moment for this H2O molecule. There is a resultant dipole moment for this HCl molecule, and there is no dipole moment for this CO2 molecule. And so any molecule whose dipole moment is 0, and what you call that? Non-polar molecule. So any molecule whose dipole moment is not 0, what you call that type of molecule? Polar molecule. I hope you have understood. Right? Then we can have dielectrics. Okay. There are two types of dielectrics. First one is called as non-polar dielectric. Non-polar dielectrics. Other one is polar dielectrics. Right? What is non-polar dielectric? Dielectric which is made up of non-polar molecules. So any dielectric which is made up of non-polar molecules. So non-polar molecules. And what is polar dielectric? Any dielectric which is made up of polar molecules. Which is made up of polar molecules. Right? So for example, if you are having a dielectric slab, let's say a dielectric which is in the form of a slab. So non-polar, center of positive charge coincides with center of negative charge. So which is made up of non-polar molecules. Right? And this is the way a dielectric look like. What type of dielectric? Non-polar dielectric. So dipole moment for this one is 0, dipole moment for this one is 0, dipole moment for each and every molecule is 0. So dipole moment for each and every molecule is 0. The overall net dipole moment is also 0. So dipole moment of this slab also 0. Right? Now, polar dielectric. Polar dielectric means which is made up of what type of molecules? Polar molecules. So polar molecules, let's say this is one polar molecule, this is another polar molecule, this is one polar molecule, this is another polar molecule, this is one polar molecule, this is another polar molecule, this is one polar molecule, and this is another polar molecule. This is one, let's say this is one polar molecule, and this is another polar molecule. Right? I told you that polar molecule, it is having certain dipole moment. You see now, the dipole moment of this one is in this direction. For this one, it is in this direction. Both of them will cancel. The dipole moment of this one is in this direction. For this one, it is in this direction. Both of them will cancel. Similarly, the dipole moments of these two will cancel. The dipole moments of these two will cancel. The dipole moment of these two will cancel. So the net dipole moment of the polar dielectric slab is also 0. So polar dipole moment of the non-polar dielectric slab is 0. Dipole moment of the polar dielectric slab is also 0. Now, all the dipoles are aligned in such a way that net dipole moment of the polar dielectric slab is 0. Have you understood? So first, what do you need to understand? What is actually a polar molecule and what is actually a non-polar dielectric? So what is actually a polar molecule? What is actually a polar dielectric? It's a very simple concept now. So center of positive charge is coinciding with center of negative charge. So dipole moment of each molecule is 0. So the dipole moment of the slab is also 0. But here dipole moment of the molecule is not 0. But the dipole moment of the polar dielectric slab is also 0. All the dipoles are aligned in such a way that the net dipole moment of the polar dielectric slab is 0. Is that clear? Is there any external electric field? There is no external electric field. So there is no external electric field. We did not apply any external field. So in the absence of external electric field, the dipole moment of the non-polar dielectric is 0. In the absence of external electric field, the dipole moment of the polar dielectric slab is 0. So finally what I can say? In the absence of any external electric field, in the absence of any external electric field, the dipole moment of non-polar dielectric slab, non-polar dielectric and polar dielectric is 0. Is that clear? It's a very simple idea. Now, so in the absence of any external electric field, the dipole moment of non-polar dielectric and polar dielectric is 0. Now, if you keep these slabs inside the external electric field, what happens? We are going to see. First one, non-polar dielectric in an external electric field. So whereas this side, polar dielectric, right, in an external electric field. Right? Now, so for example, this is a non-polar dielectric slab. Right? There is no field. Now, if I keep this slab in an external electric field, right? Now what happens? These dipoles will be stretched. Positive charges will move along the direction of electric field. Negative charges will move opposite to the direction of electric field. So the dipole is stretched. Right? The dipoles are stretched. Now, as you can see here, all the positive charges and all the negative charges which are side by side, they will get cancelled with each other. This positive and negative cancels, positive and negative cancels, positive negative cancels, positive negative cancels, positive negative cancels, positive negative cancels. We are left with this side positive charges and we are left with this side negative charges. And you know very well, electric field is always towards the negative charge. Electric field is always away from the positive charge. slab, there are two electric fields. One is external electric field. Let me call it as E naught. External electric field. Or let me call it as E naught. And here there is positive charge, there is negative charge. So there is another electric field created inside. That is called as induced electric field. What do you call that as? Induced electric field. So E naught is called it is nothing but external electric field. Right? That is the field that we are applying. And EI, it is nothing but induced electric field. Right? So what is the net electric field inside the slab? The net electric field inside the slab is equal to E naught minus EI. So which is less than E naught or more than E naught? Which is less than E naught. So electric field is reduced or electric field is not reduced. Electric field is reduced. So what is the conclusion here? So if you place a non-polar dielectric in an external electric field, inside the slab electric field is going to be reduced. So electric field is reduced. Right? And it has been observed. Up to here is it clear? Up to here is it clear? Right. Now here dipoles are stretched. Literally the stretching of dipoles. The stretching of dipoles is called electric polarization. What do you call that? Electric polarization. The stretching of dipoles is called electric polarization. So where they are getting stretched? Inside in an external electric field. So the stretching of dipoles is called what? Electric polarization. Is that clear? And this is the way a non-polar dielectric behaves. So there is an electric field. Let's say E naught. In a space there is an electric field E naught. Right? If you keep a non-polar dielectric, what happens? Inside that dielectric slab, electric field will be reduced. Is that clear? Right. Now, let me talk about polar dielectric in an external electric field. External electric field. Right? Polar means what? So there is a dipole moment. Now see what happens here. So let's say there is a negative charge, positive charge. There is a negative charge, positive charge. There is a negative charge, positive charge. There is a positive charge, negative charge. So there is a negative charge, positive charge. There is a positive charge, negative charge. And then you'll be having, so there is a negative charge, positive charge. There is a positive charge, negative charge. And let's say there is a positive charge and negative charge. Something like this. Now see carefully. Right. All the dipoles are aligned. All the dipoles are aligned in such a way that net dipole moment of this polar dielectric is how much? 0. Now, if you keep this one in an external electric field, what happens now? Here, there will not be any stretching of dipole because already dipole moment exists. So there will not be any stretching. All the dipoles will be aligned along the direction of dipole sorry, all the dipoles will align along with the direction of electric field. So there is a dipole here, there is a dipole, there is a dipole, there is a dipole, dipole. So dipole moment this way, dipole moment this way, dipole moment this way. So for each and every molecule there is a dipole moment. So the dipoles are aligned along with the direction of electric field, right? All the positive charges will cancel with negative charges nearby. All the positive charges will cancel with negative charges nearby. So what we are left with what? Positive charges. Here what we are left with? Negative charges. So inside the slab there are two electric fields. What are they? External electric field. Other one is induced electric field. So what is the net electric field inside the polar dielectric? E naught minus Ei. So what is E naught? External electric field. External electric field. What is Ei? Induced electric field. And the net electric field E naught minus Ei, which is less than E naught. Now electric field is reduced, not reduced. Electric field is reduced. So electric field is reduced. Right? Now see carefully. Whether it is a polar dielectric or non-polar dielectric, if you keep them in an external electric field, polar or non-polar, any one of them. So this side we are having negative charges and this side what we are having? Positive charges. So positive charge is there, negative charge is there. So there is a dipole moment created. So there is a dipole moment, there is no dipole moment created. There is a dipole moment created. So this is for either non-polar or polar dielectric. Starting we have discussed. What we have discussed? For a polar dielectric slab, dipole moment is 0 in the absence of electric field. Non-polar dielectric, whether polar dielectric slab or non-polar dielectric slab, in the absence of external electric field, dipole moment of both of them is how much? 0.